Hello again. We are going to end this unit on trigonometry by talking about the ambiguous case. This is lesson 9.9, so let's get started. First, let's remember what I need to use for each specific situation, and that's the table that I went through with the last lesson, which was using the cosine rule and sine rule and what to use when. I've got this extra column at the end because I want you to know why we can use those rules. If I know the three sides of any triangle, then I know that that triangle is going to be unique. So that means that the angles will have to be a certain measurement. That's based on side-side-side congruence that you learned in geometry. If you know all three sides, then that triangle is unique. Now, similarly, if I know two sides in the included angle, that was called side angle side. That was another congruence postulate that you learned in geometry. That triangle is also unique. Two angles and the included side would be angle side angle, another unique triangle, and two angles and a non-included side would be angle angle side. That's another congruence postulate where you create a unique triangle. The last one, however, is two sides and a non-included angle. That's side side angle, and if you remember from geometry, that didn't work. That doesn't create a unique triangle. In fact, it can create up to two. Okay? It can create a unique triangle. Let me correct myself. It can create a unique triangle, but it doesn't have to. Sometimes it creates two solutions. So let's look at this example right here. I have that angle A is 30, side B is 7, and side A is 5. So I've drawn the 30-degree angle. I know that one of the sides that touches it is length 7, but I don't know the length of side C which would touch it. So I've got that straight arrow going to an indefinite length. I don't know how long that side is. I wasn't told. I'm not asked to figure it out either. But I do know that the side that is opposite the 30-degree angle has a length of 5. So what I know is I could draw it there. I just did a little bit of trial and error and drawing things to scale. And so I could draw the other side there, and so then I would know the length of side C. I could figure it out. I could figure out the other two angles. So if that side does go there, then I have an angle that is 44.4. I can figure out the rest by sine rule. But notice that I can also move the side over here and it's still length 5. I haven't changed the length of it at all, and I've just moved it to a different location. And if I put it there, the angle that's in the triangle now is 135.6. So those are the two different things that the angle could measure. So why do both solutions work? Well, if I use the sine rule with that information, I've got A, I've got B, and I've got side A. So I'm going to use this version of the sine rule. A over sine A equals B over sine B. And if I plug things in, I get 5 over sine 30 equals 7 over sine B. If I cross multiply, I get that 5 times the sine of B is 7 times the sine of 30. So if I solve for the sine of B, I get 0.7. But notice that the two angles that I got, those purple angles, they each have a sine of 0.7. So how do I know which one is right? And furthermore, why do they both have the same sign? Well, the calculator will always give us the answer that's closest to 0. So it's going to give us the 44.4, and we'll just assume that it's the only angle that will work, the only angle that's correct. But that's not true. If I'm using the sine rule, then I need to understand that there's another angle that has exactly the same sign. Okay? So how do I get that other possible solution? Well, looking at the two solutions I got, 44.4 and 135.6, that's no coincidence that they add up to 180 degrees. So when the calculator gives me one answer, then I will subtract that answer from 180 and I will get the second answer. Okay, so there will always be two angles that have the same sign, and that's the relationship between them, is that they are supplementary. They add up to 180. So that's how I get the 135.6 degrees as the other possible angle. So here's another example just to show you what I mean. I need to find angle B and angle C if I know that angle A is 25, side B is 9, and side A is 8. So I'm going to use the sine rule. That's when this happens, is when I'm using the sine rule. It does not show up for the cosine rule, as you remember from that table, because the sine rule is the only one that has that side-side angle thing. So I set it up as A over sine A equals B over sine B. Plug in what I know, 8 over the sine of 25 equals 9 over the sine of b. Cross multiply, 8 times the sine of b equals 9 times the sine of 25. So I solve for the sine of angle B and I get 0.475. My calculator tells me that based on the fact that the sine of B is 0.475, I should know that B is 28.4. That means that if A, remember A is 25 and B is 28.4, then if I subtract those two angles from 180, I will get 126.6 degrees as my angle C. Now, we knew that the sine of angle B was 0.475, meaning that one possibility for angle B was 28.4. What's the other possibility for angle B? It's the supplement of that, 180 minus that, which is 151.6. So now if angle A remains unchanged at 25 degrees, angle B is now 151.6 degrees. If I subtract those two from 180, I get that C is 3.4 degrees. Both of those are valid triangles, and I don't know which solution is the one that they want. So I have to list them both. Okay? But remember, you have to check the third angle, and I'm going to give you an example of why you have to do that. Again, I'm going to be asked to find angle B and angle C if I know that angle A is 65 degrees now, B is 6, and A is 7. Sine law again, A over sine A equals B over sine B. Plug in what I know so that 7 over the sine of 65 equals 6 over the sine of B. Cross multiply, and I get that 7 times the sine of B equals 6 times the sine of 65. Solve for sine B, and I get the sine of B is 0.777. That means that either B is 51 degrees, and then figuring out C the way I did before, C is 64 degrees, or B is 129 degrees and C is negative 14 degrees. That's why you need to check the third angle. That third angle can't be negative. So if you look at my two possible solutions there, that second one doesn't make any sense because C can't equal negative 14 degrees. So that's the ambiguous case. It only shows up in the sine rule. And if you have any questions about this, any of the examples I did, please let me know and I will see you tomorrow.